One of the most anticipated astronomical events is the supernova of Betelgeuse, located on the shoulder of the Orion constellation. Betelgeuse is a red supergiant star approaching the end of its life. Despite being one of the brightest stars in the night sky, something curious happened in late 2019. It began to lose brightness. This phenomenon was so evident that many people, even with the naked eye, noticed the reduction in its luminosity. For several months, the star became fainter, raising doubts about whether Betelgeuse had reached the end of its journey. After a few months, surprisingly, the star's brightness returned to normal. Astronomers, using some of the most powerful telescopes, were astonished to discover the reason for this significant weakening. It appears that Betelgeuse is on the verge of exploding, reaching the end of its existence. But when and why? And will this pose a danger to Earth? We will find out today. Betelgeuse, this bright ruby star, is located on the right shoulder of the Orion constellation, the Hunter. Also known as Alpha Orionis, it is the second brightest star in the constellation, second only to the blue supergiant Rigel. Betelgeuse is fascinating for stellar studies due to its variable nature and its peculiar name. Stars with the name Alpha are usually the brightest in their constellations, and even though Rigel is brighter, Betelgeuse is considered Alpha Orionis due to its name, brightness, size, and reddish hue. It is one of the most well-known and visible stars, being the seventh brightest seen from most of North America, Europe, and Canada, and the 10th brightest overall. Although Betelgeuse is often depicted as Orion's right shoulder in many old star maps, its exact significance is still unknown. After all, Orion is frequently associated with a giant, a warrior, a hunter, a god, or some anthropomorphic or animal figure in ancient mythology. Surprisingly, astronomers cannot determine the exact distance from Earth to Betelgeuse, but they believe it is between 430 and 724 light-years away. It is the brightest and closest red supergiant to us in our galaxy. With 16.5 times the mass of the Sun, Betelgeuse has 126,000 solar luminosities and is visible from 548 light-years away. Its surface temperature is 3,000 Celsius, cooler than the Sun, and only about 13% of its energy is visible to our eyes. If we could see light at all wavelengths, Betelgeuse would surpass Sirius as the brightest star in our night sky. It is so large that if it replaced the Sun in our solar system, it would extend beyond the asteroid belt and reach beyond Jupiter, completely engulfing Earth, Mars, Venus, and Mercury. Betelgeuse loses about one solar mass every 10,000 years. A nebula surrounds the red star due to the irregular ejection of material in all directions. A cloud of material 250 times larger than the star surrounds it, with an estimated size of 30 astronomical units, or 30 times the distance between the Sun and Earth. Estimated to be between 9 and 10 million years old, Betelgeuse is considered relatively young. Supergiants or red giant stars are believed to be approaching the end of their existence. When a star is born, it is made of hydrogen, which fuses in the star's core under the force of gravity, creating helium in a nuclear explosion. Much thermal and luminous energy is released during this process. As the star ages, its main fuel, hydrogen, runs out, and helium begins to combine with carbon to form carbon. After helium is used up, neon eventually combines with carbon to form iron. When this happens, the fusion of neon with iron absorbs energy instead of releasing it. Since there is nothing to oppose the very powerful gravity of the star when iron begins to fuse, the star collapses, resulting in a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change color throughout their existence, from the youngest and hottest blue colors to the older and cooler red varieties, depending on the stage of their stellar evolution. Greek scientists like Ptolemy in the 2nd century strangely referred to the color of Betelgeuse as having a reddish tone. However, 3 centuries earlier, Chinese astronomers characterized the star as having a yellow appearance, possibly indicating that Betelgeuse was previously a yellow supergiant. Larger stars often burn their hydrogen more quickly and die earlier. Despite being only about 10 million years old, Betelgeuse is certainly approaching the end of its life, while our Sun, at about 5 billion years old, is still in its prime. Additionally, due to Betelgeuse's proximity to the end of its life, a supernova may occur soon. However, the exact date of Betelgeuse's supernova is widely contested. Betelgeuse undergoes two cycles of weakening and strengthening, the second of which occurs approximately every 5 years and lasts about 100 days. It is believed that the star's outer layer expands and contracts during this cycle, altering the star's circumference and average temperature according to each stage of the cycle. The inconsistent weakening of Betelgeuse in 2019 and 2020, followed by a brief restoration of its usual brightness, attracted much attention. According to astronomers, this may indicate that the star is about to die. Betelgeuse has been the subject of intense study since the 1st century BC, but why did it suddenly weaken outside its usual cycle? It seems that Betelgeuse was ejected from its home in the Orion OB1 association, which comprises the stars of Orion's belt, and has been seen moving through interstellar space at a speed of 30 kilometers per second. An extensive shockwave, over 4 light-years wide, is being produced by this fast-moving star. Estimating distances to red supergiant stars like Betelgeuse has been challenging in astronomy. Determining the exact diameter of Betelgeuse has been challenging for several reasons. Betelgeuse is a pulsating star, so its diameter changes over time. Optical emissions change color and weaken with distance from the center due to limb darkening. Therefore, there is no distinct edge to the star. The circumstellar envelope, composed of material ejected from the star that emits and absorbs light, makes it difficult to define Betelgeuse's photosphere. The apparent size of the star varies depending on the wavelength used, making it difficult to compare observations within the electromagnetic spectrum. Measurements can be taken at various wavelengths, and reported diameters can vary by up to 30 to 35%. Photos taken by the Very Large Telescope Interferometer in July 2009 and released by the European Southern Observatory showed a massive gas plume reaching 30 astronomical units from the star in the surrounding atmosphere. The size of this mass ejection, one of many events in Betelgeuse's atmosphere, is equivalent to the distance between the Sun and Neptune. Astronomers have discovered at least 6 layers surrounding Betelgeuse. Unraveling the mystery of mass loss in the final stages of a star's life would be possible to understand the reason for the dire fate of these stellar giants. In addition to issues related to the star's diameter, there are concerns about the complex dynamics of Betelgeuse's expanded atmosphere. Red supergiants play a significant role in recycling the matter that makes up galaxies, although it is still unclear how mass loss occurs. Thanks to advances in interferometric techniques, astronomers may be close to solving this problem. Using the Hubble and other observatories, astronomers found that the star rejected a considerable amount of its visible surface in 2019, generating a massive surface mass ejection. This has never been seen before in a star's behavior. Our Sun regularly ejects parts of its thin outer atmosphere, the corona, in a phenomenon known as coronal mass ejection. These events are orders of magnitude weaker than what was observed in Betelgeuse. The surface mass ejection of Betelgeuse, or SME, ejected 400 billion times more mass than a typical coronal mass ejection, explaining why, by mid-February 2020, Betelgeuse had lost about 3 times more brightness, going from magnitude 0.5 to magnitude 1.7 after starting to decline sharply in October 2019. Until February 17, 2020, Betelgeuse's brightness remained stable for almost 10 days, and the star began to brighten again. However, 5 days later, Betelgeuse appeared to have completely stopped weakening, effectively ending the weakening episode. Given that there were no significant changes in the infrared on February 24, 2020, it seemed that the recent visual weakening was not related to the expected core collapse. Another study on that day concluded that the star's weakening was likely caused by large, grainy circumstellar dust, ruling out dust absorption in the study that used sub-millimeter wavelength measurements. But the weakening seems to have been caused by large stellar spots. Additional analyses showed a dramatic increase in Betelgeuse's brightness. The discovery of a second dust cloud from Betelgeuse, linked to a recent dimming of the star's light, was revealed by astronomers on August 30, 2020. Last June, it was suggested that a spot on Betelgeuse's photosphere could be the cause of the dust, and in August, a second independent investigation confirmed the initial hypotheses. The dust is believed to have been created by the gas the star expelled as it cooled.